Welcome to this episode of How Do We Pass Our Common Core Algebra Regions. Today we're going to be looking at inequalities, and I hope I can do a very good job. An inequality is nothing more than a statement saying that two quantities are not equal. In other words, for example, let's say you have 3. Is 3 and 5, and you want to compare these two numbers. Well, 3 is less than 5. See that? Now I'm doing this less than symbol in the shape of like an L, because with your left hand, okay, if you put your left hand like this, see, an L, less than, got it? Okay, so that's basically what it is. With your left hand, you form an L, and that tells you what the less than symbol looks like. All right, now symbols of inequalities. Less than, okay. Less than or equal to, greater than or equal to. Got it? I'm not gonna start labeling it. It's your job to label it, okay? Less than or equal to, greater than or equal to. So how do I solve inequalities? Well, first we need to understand something. 3 is less than 5 in comparison. But what happens, remember when you solve equations, what you do to one side, you do to the other? Well, I want to multiply this side by -1. Therefore, I have to multiply this other side by -1. So what are you trying to do? Like, what are you trying to teach me right now? Well, if you multiply this, you get -3, right? And then if you multiply this, you get -5. So, well, is -3 less than -5 now? No, -3 is closer to 0 on the number line. Look, let's look at the number line. Okay, this is 0. This is -1, -2, -3, 4, -5. See, it's further away from 0, so therefore -5 is less than -3. So I could swap them, or I could just say that -3 is greater than -5. So notice what just happened. When I multiply, I could have multiplied by -2. If I had multiplied by -2, then I would have gotten -6 and -10. Still, -6 is greater than -10. So what is that telling me? That when you multiply or divide, okay, I just multiply by it. When you multiply or divide by a negative number, the inequality symbol must switch place, not switch directions, sorry. Got it? Okay. With that in mind, now we are ready to start solving inequalities. So let's have our first something easy. 2x is greater than, 10. Okay, just for the sake of having it. So, and we're gonna have also -2x greater than 10. See what happens. Let's solve this one. So, you solve an inequality the same way you solve an equation, okay? And I gave you the golden rules in the previous episode. So let's see. Do I have distributive property? Of course not. How about like terms? Fractions? No. How about like terms? No. How about variables on both sides? No. Additive inverse? No, there's no number adding to the variable. What about multiplicative inverse? Yes, we do. We have multiplicative inverse. Only these ones I'm gonna do it, okay? And then later on we just divide. So the multiplicative inverse of 2, since this is 2/1, then this is gonna be 1/2. Beker, you're making life miserable. I know, that's my job. And I love it. Okay, so 2x times 1 is 2x divided by 2. The idea behind using the multiplicative inverse is basically the same as dividing by 2 on both sides. So this is x because the 2 cancel out and the 1s cancel out, right? And then of course this is 10 divided by 2, which is 5. Now, did I divide or multiply by a negative? No. So then the inequality symbol remains intact. Now let's discuss this. What in the world is this? X greater than 5. Well, x can be any number. But in this case, it's telling you that x will represent all the numbers that are bigger than 5. I mean greater. If I put bigger, you might think that I want to make a bigger number. Anyways, got you. Alright, so anyways, where was that? Oh yeah. So x can be 6, 7, 8, 9, 10, blah, 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 all the way to infinity. So you want to represent this in interval notation. Well, can x be 5? No, it has to be greater. So it cannot be 5, right? So x is not 5. You see that? But it can go all the way to infinity. All right, you could do that, or you could represent it like parenthesis means that this is excluded. Now, why is infinity excluded? Because infinity is not a number; it's just a symbol. Now you could do it like this too, including, and then we'll put like 6, and still put infinity like that. See that? This what is this? Brackets? Yeah, brackets represent inclusion. Okay, so look, parentheses excluded, brackets included. All right, now let's try the other one. So here I have negative 2x. Okay, so I'm still, this time I'm not going to use the multiplicative inverse. I'm just going to divide by negative 2. Okay, so x and then 5. Now, tell me what's going to happen here. Did I divide by a negative? Yes. So what's going to happen? Correct. The inequality symbol switches. What does this mean? X represents all the numbers that are less than 5. So 4, 3, 2, 1, 0, blah, blah, blah. So now your solution set is going to look like this. It's going to go from negative infinity all the way to, you're going to put 5, but not including it. That's it. Okay. Now let's get ready to rumble and let's represent. Let's do some damage. Let's do more difficult ones. So please pause it if you need to, but you also might need to copy this down. All right. 0 greater than 3x minus 3 minus 6. All right. So it's saying that this right side should be less than 0, or 0 should be greater than the right side. So I don't know how we're doing this, but what I'm going to tell you is that we're going to use the golden rules to solve linear equations because it's solved the same way. So first, do I have distributive property? No. Do I have fractions? No. Do I have like terms? Yes, right here. So we're going to combine these like terms. So we're going to have 0 greater than 3x minus 9, okay? And now, do I have variables on both sides? No. Do I have additive inverse? Yes, I do. Look, there is a subtraction being happening here. So that means that I should add 9 to both sides, okay? That's what the additive inverse does. I'm not gonna divide by 3 and say that's additive. No, that's division. All right, anyways. So what you do to one side, you do to the other. Remember, the inequality symbol is the one that determines which side is which. So I got 9 less than, have I multiplied or divide by a negative? No. Okay. Now divide by 3 on both sides. And we get that 9 divided by 3 is 3. So 3 is greater than x. If 3 is more than x, that means that x is less than 3. So do me a favor and switch places. Not switch places. Like do a reflection of this. If you do a reflection, what's going to happen? The x goes to this side, the 3 goes to that side. And if you're doing this, then the symbol is got to change. See? 3 is still more than x. Now x represents all the numbers that are less than 3. Like 2, 1, blah, 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 blah. Okay, then. Now if I was to represent that on the number line, how would I represent it? Well, take the number line, okay? And we're gonna make a scale, okay? First of all, we should always use rulers. I just don't know what I did with mine. I'll find it. I don't have a problem with that. Or I just brought one. Okay, x is less than 3. So let's have the number line. So we have 0, 1, 2, 3, 4, -1, -2, and blah blah blah. So x represents all the numbers that are less than 3. So you're gonna put a empty circle or empty dot or however they call it, but it's gonna be empty, like my feelings right now. And since x represents all the numbers that are less than 3, you're gonna go with the ruler and you're gonna go to your left, denoting, okay, telling whoever is looking at the graph that you're going to the left, that you're going in decreasing mode, that all the numbers that are less than 3, not including 3. You see that? Now, what would have happened if this was not a less than, if it was a less than or equal to? Well, then you would have to put a full circle, like tick, 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 fill it in, telling people that yes, 3 is also part of the solution. Because if x is less than or equal to 3, that means that it could also be equal. Got it? All right, cool then. Let's do another one. Let's see. Something nice, oh, okay, yes. Let's do this one. This one's gonna be popping, son. 3 minus 2 times n minus 4 greater than -1. Okay, this one sounds like fun. So let's see. Again, with the golden rules. Do I have distributive property? No. What? No. Yes. Where do I have distributive property? Right here. Oh, okay, fine. So then, yes. So then we do distributive property. 3 is not part of the distributive property. Distributive means that you're going to distribute multiplication over addition. This is the one that's multiplied. So -2 times n is -2n. Okay, distribute. -2 times -4 is +8. Greater than -1. Got it? Okay. So now, what? Well, do I have fractions? No. Like terms? Yes. 3 and 8 on the same side. Okay, so that's 11. And so far, I have not divided by a negative number, so we're good, right? Or multiplied. Okay. So now what? Variables on both sides? No. Additive inverse? Yes. The additive inverse, there's always a plus or a minus between a number and the variable, or the variable with the coefficient. So yes. Now, what is the additive inverse of 11? Look, it's 11, not -11. 11 is positive. Oh, okay. So it's -11, sir. Okay, cool. Notice that I'm not multiplying or dividing by a negative. I just subtracted a number. Okay, so now -1 minus 11 is -12. Divide by -2. And n turns into, and this turns into 6, right? Okay, what's gonna happen? Yes, exactly. This changes because I divided by a negative. Beautiful. So this is basically how you what do you call it? That's how you solve inequalities, linear inequalities in one variable. Now you wanna graph this, so you with the straight ruler, you go like this. Yo, I just did it. Nice. Okay, and you make a little number line. Let's say n is less than 6. So I need 6. So it's gonna be 6, 7, 5, 4, 3, 2, 1, 0. Anyways, the idea is this: n is less than 6. N represents all the numbers that are less than 6. So you go to 6 and you put an empty because it's not less than or equal to. And since it's less than, just go with the ruler to the left and put the arrowhead stating that it goes on forever and ever and ever. Okay. Let's do one more. Okay. Oh, imagine if I was using this paper. Okay. I want to have an inequality that has some type of something. Okay. Let me see. 26 plus m is greater than or equal to 5 times -6 plus 3m. Sometimes you might complain that I'm covering everything, but you know what? That's why I am dictating it. Oh, okay. So once again, it's an inequality, but we still follow the golden rules. So do I have distributive property? Yes. This time I'm gonna get serious. 26 plus m greater than or equal to, and then use distributive property. All right. So 5 times negative 6 is negative 30. And I should not be writing on this one. I should be writing like this. Sorry guys, I'm gonna waste your time a little bit. Okay, beker, you just found a way to be more efficient. Now I'm not gonna kill that many trees. All right, here we go. Now it's the green. Oh my God, beautiful background. Caught you again. Sorry. All right. So 5 times negative 6 is negative 30. 5 times 3 is 15. So plus 15m. Okay. And now fractions, no. Like terms, nope. Nope. You see, you might say, yeah, like terms right here. No. That's why I created that rule. Like terms on the same side, because the next rule will take care of these two things. No like terms. Okay. Variables on both sides. Yes. Look. Usually I say to get rid of the lesser one. So let's get rid of m. And to be more politically correct, 1m. Okay. So these m's cancel out, becoming 0. Bring down the 26. Greater than or equal to. That was my phone. Negative 30. And then 15 minus 1 is 15m minus 1m is 14m. Okay. Now, do I have additive inverse? Of course, right here. This 30 is being subtracted from this, right? So plus 30. Remember, additive inverse is the opposite. This is 56 greater than or equal to 14m. And now we divide by 14, right? Okay. So now what is 56 divided by 14? Let me see. 4 times 4. Oh, that's easy. So 4. Okay. Did I divide by a negative or multiply by a negative? No. So greater than or equal to 1m. Now the thing is this. Greater than or equal to 1m, blah, blah, blah. You need to understand what this is. This one, yes, you read it as 4 is greater than or equal to m. So 4 is the maximum value. So that, what does that mean? That m is going to be anything that is less than 4. 4 is greater than m, so m has to be less than 4, right? Or you could just switch them around. I prefer that you switch them around so you understand. You know what happens to this greater than or equal to? Turns into a less than or equal to. You put the 4 and it becomes easier to graph. To graph, you go like a straight line. You put the 4 here, the 5, the 6, the 3, the 2, the 3, the 2. And what do we know? M is less than or equal to 4. So therefore, M is going to go here, but not anymore as an empty circle, because look, less than or equal to, that means that the 4, that M can actually be 4. So it's full. And then we're talking about less than, still going to the left. That's not a problem. If it was greater than, it will go to the right, okay? It just so happens that all the problems that we've done are to the left. To the left, to the left. Everything you want to go to the left, right? Now, of course, you want it to look nicer. You want it to be nicer. Sure. You just look at this problem right here. That's the one that we just solved right here. All right? So now I'm gonna point out some additional problems you could do on your own, and then we check what's going on. If I had the thingy, right? Okay. Ooh, beautiful. This one right here. 15 and 17. Okay. Copy them. Got it? All right, so now let's check what the answers are. 15 and 17, right? Right here. If that's what you got, you're good. If not, we're gonna have to revisit that. So now we're going to be, we understood that, and we are going to move away from the from one variable. Look, only one variable was given here, x, r, only one variable. Now we're going to graph linear inequalities. It's like graphing linear equations, but with the inequalities. So here we have the inequality, right? Y is greater than or equal to negative 3x plus 4. So we're going to do this in 2 or 3 different ways. First of all, we already spoke about the slope-intercept form. We already know how to identify the slope and the y-intercept of an equation when it's solved for y. Well, it's the same principle for the inequalities. So let's see, what is the slope of this inequality? The slope is negative 3 over 1. So we're going to write slope is negative 3 over 1. Okay? And now I see that you cannot see, so I'm going to have to use the marker. Oh my God. It doesn't matter. All right, so let's see now. Negative 3 over 1. So negative 3 over 1. And the y-intercept is 4, so B is 4. And of course, the coordinates of the y-intercept are 0, 4. So I'm going to start graphing at 0, 4. So 0, 1, 2, 3, 4, right here. Okay, that's my point. Now, the slope is negative 3 over 1. In other words, 3 down and 1 to the right. Or 3 up and 1 to the left, as we spoke before. So let's see now. 1, 2, 3, and 1 to the right. Okay, 1, 2, 3, 1 to the right. Okay, that should be enough to sketch my graph. Okay, see it right here. So I go and see straight line. See, that's a straight line. Put the arrow heads because we don't have any limitations. Okay, and now what's peculiar about it? Well, that the inequalities, when you graph them, they have to be, you have to have a solution, like a shaded region. So, but how do I know which one is the shaded region? Well, I'm gonna do the long way. You choose a point on either side of the inequality, either above or below. So let's choose something below. Let's try negative 2, 1. Let's try this point, negative 2, 1. All right. So now, a piece of paper, I'm gonna test my solution. So what was the point? Negative 2, 1. Okay. So I write the inequality. Y is greater than or equal to negative 3x plus 4. Now I'm gonna solve the inequality. Not solve the inequality, test the point. What was the point that I was testing? Negative 2, 1. All right. So this is x and this is y. So now let's substitute in here. So y is 1. So 1 is greater than or equal to negative 3 times the value of x, which is negative 2 over here, okay, plus 4. 1 is greater than or equal to, okay, negative 3 times negative 2 is 6, plus 4, 10. Is 1 greater than or equal to 10? No. So this point does not test true. So this side of the line is not going to be shaded. So therefore, you don't need to test the other points. You just need to shade the other side. And that, my friends, after you do that, you put solution. If they ask you to test a point on the solution, then just choose a point anywhere here. Okay, any point above this line is going to be, oh my God, texting me. Any point will be a solution. Okay, now what else I forgot to tell you? Yes, I forgot to tell you the following. So this is done. I was lucky that the symbol was greater than or equal to. But I'm going to tell you right now how you're going to sketch your lines. If the symbol is less than or greater than, then you're going to have a dash, okay, dashed line. If your symbol is less than or equal to, or greater than or equal to, meaning that the values will be included, then you do a solid line like we just did. Okay, no gaps. Solid line. Why? Well, here, what this is saying is that any point you choose on the line is not going to be a solution. This one is saying any point that you choose on the line is going to be a solution. But you don't want to pick points that are on the line like this, this, and that, because that is not going to give you any information of what area to shade. Got it? All right, let's move on then. Oh no, let's not move on. Let's use the calculator. Fine, we're gonna use the calculator for this. So you still see that? Cool. So we turn the calculator on, we press Y equals, we remove whatever I was doing in there, and let's sketch the inequality. Okay, let's see now. Hopefully you could see this. All right, so what is it that I had? Inequality. So there are different ways of doing this. You could go here to the left and highlight this. Whether you have a TI-84 or a TI-83 or a TI-84 plus CE, the only difference is that this one has color. And you press enter. See, you heard what I said, right? You press enter. So now you're gonna press enter until this, where it says line, okay, in this calculator, and the other one is not gonna say it, this turns into a symbol of your liking. Here, look at this triangle right here. Let me zoom in. Okay, you see it looks like a greater than. How do I know that? Well, look at this one. This one looks like a less than. See that? Greater than, less than. So what do I know about my equation? Inequality. That y is greater than. Okay, so I'm gonna choose the greater than. Be careful if the y was on the other side, but anyways, that's another story. So we choose greater than. Okay, so okay, now all I have to do is type in the inequality. So negative 3x, all right, plus 4, and then you hit the graph button. Okay, you hit the graph button right here, and look at what's gonna happen. You're gonna have your line, and it's gonna, and look at the shaded region. It gives you the shaded region, okay, just like we had over here. Okay, all right, now let us do another one so I can show you a different thing on the calculator. All right, so we have this inequality. Is it solved for y? Yes. If it's not solved for y, you solve for y. Okay, the same way you solve a linear equation for y, you could solve the inequality for y. This one is just greater than. So let's see. Let's graph it without using the calculator. For example, identify the slope. The slope is negative 1 over 1. All right, look, negative y is the coefficient of x, and the y-intercept is negative 5. So I'm gonna start graphing at 0, negative 5. So let's see, 0, negative 5, 0, negative 1, negative 2, negative 3, negative 4, negative 5. That's my point. Now, the slope is negative 1 over 1, meaning 1 down and 1 to the right. Now, if you cannot go down to the right, remember, I already explained to you how to work with the slope. If you cannot, the line is gonna look like this. You already know it, look. Now, if you cannot go down to the right, then go up to the left. It's the same thing, look. Okay, and then you sketch your line. Now notice that the symbol here is greater than. It's not greater than or equal to. So therefore, my line is going to be a dashed line. To infinity and beyond. See that? Dashed line, boom, boom, arrowheads, boom, boom, arrowheads. And now, I'm gonna tell you a secret, so you don't get confused. You still have to try points if you are required to do so. But let's go back to the previous one. Here the symbol was greater than or equal to. The or equal to is not too relevant for what I'm about to tell you. If the symbol is greater than or equal to whatever, then you're gonna shade above the line. If it's less than, you're gonna shade below. Without testing the points, yes. So here, for example, y is greater than blah, blah, blah. Well, is this greater than, you're gonna shade above. So is this above the line or is this above the line? Correct. See that? And it was dashed because the points on the line are not. Kobe, are you seriously? Dog, stop. That's my dog. If you eat the wire, I will put you for adoption. Alright, well, since I'm joking already, so got you. Okay. Where was I? Anyways, any point you're choosing here is going to be a solution. If on the regions they ask you, choose a point that is not a solution of the line, then you pick a point here or any point on the line. Got it? The calculator, right? So here, let's put that equation here, that inequality. I don't know why I keep saying equation. So it was a greater than, so I already have a greater than, so I don't need to do it again. Negative x minus 5 graph, and what I tell you, look at this, beautiful. The only thing is that using this method, the calculator will not tell you whether the line is dashed or not, so you have to do it. But I'm not sure, if you press the apps button and you go down, well, I'm gonna go up actually. If you go down, down, whatever, to where it says inequals, you press enter. Now the calculator just entered the inequality mode. So whenever you press y equals to, okay, you're gonna go again to the left, but now you're gonna have more options. So blue, fine. Now y equals, no, you want y is greater than, so you want this one. See that? Now you press OK. Now it changed only in this calculator, okay? In the TI-83 doesn't have that app. I don't think so. So you graph. Guess what? Now you get your dashed line. So zoom in, zoom in, zoom in, and you get your dashed line. As simple as that. Okay, now let us continue with this. I'm not gonna use the calculator anymore because I know how to graph without the calculator. I want to find one that is kind of difficult, and I think I just found one. Remember, if it's not solved for y, you have to solve for y. You already learned how to. Okay. So here, is it solved for y? Yes. So all I have to do is identify the slope and the y-intercept. The slope is positive 7/4, and you have the y-intercept is 2. Okay, now all I have to do is go to 0, 2 and go 7 up and 4 to the right. So look, 1, 2, 3, 4, blue, cannot go 7, and can I go 4 to the right? Yes, but no, cannot go 7 up. Doesn't matter. Up to the right, the line is gonna look like this. So up to the right is the same thing as down to the left. So I'm gonna go down 7, 1, 2, 3, 4, 5, 6, 7, okay. And I am going to do que estrómpito, estúpido. I should have never labeled this. Anyway, this is not the point, guys. I'm sorry. So go down 7 and then 4 to the left. 1, 2, 3, 4. This is the point, okay? Forget about this. This does not exist. So I went down 7 and 4 to the left. And now all I gotta do is sketch my graph. Now, is it gonna be solid or dashed? It's gonna be solid because it's a greater than or equal to. Okay. So look, straight line. Okay. And now where am I gonna where am I gonna shade? I'm going to shade above the line. Well, what is above the line? Definitely this is below the line. How do I know? Because the y values are decreasing here. Okay? Here the y values are increasing. So, oh, I'm running out of ink. Okay? And now to the test. Y equals, and now I have what is the greater than or equal to? Okay. So greater than or equal to. So boom. Oh my god, what just happened? Okay, greater than or equal to, and it's going to be what was it again? 7/4x plus 2. Okay, alpha, sorry, no, let's clear that. And alpha y equals, press fraction, and then 7/2x plus or minus 4 plus 2. 4 plus 2, and boom, and voila, that's what we had. Dashed, and that's what we had. Beautiful, right? Okay. Let me see. Alrighty, here we hit the jackpot, the mother load. So I'm supposed to graph this, not a problem. Now x is less than -5. How do I graph this? Well, the same way you would graph the equation x equal to -5. And what do I know about x equal to a number? That it is going to be a vertical line, because it's a command. Whatever y is, x is always going to be -5. So if y is negative, if y is 1, x is going to be -5. If y is 2, x is -5. If y is -5, x is -5. You see? Always -5. So now you trace your line. Now, is it going to be solid or dashed? Easy. It's going to be dashed because it's less than. Now, this is the only problem that cannot be done on the calculator. Then everything else you could do on the calculator. You cannot graph x equal to. So you have to know. Arrowhead, arrowheads. Okay. Now, where am I going to shade? Am I going to shade on the bigger numbers or on the lesser numbers? Exactly. I'm going to shade to the left. So, all right. So, that's it. Let's move on. All right. Here, we're back to x and y. So you have to solve for y. How do I solve for y? Well, easy. Move the loose number to the other side, or add or subtract the loose number, and then add or subtract the x term and divide by the y term. As simple as that. If not, then you're going to have to go back to how to solve for y. So I'm going to do it on paper right here, just in case. So I'm going to have 3x minus 2y less than 10. So let's see now. Move the loose number to the other side of the y. Well, the y is already on the other side. Look, the loose number is already on this side. Okay. Then get rid of the x term. Okay, so subtract 3x from both sides. Cancels out. Now remember, we want it in y equals mx plus b form. The slope goes first, so -3x and then plus 10. Why plus 10? Because the 10 is positive. Oh, okay. And now divide by the -2. So divide by -2, divide by -2, divide by -2, and we'll get you with that. And we got y, then we got -3. Oh, oops, sorry. Positive 3/2x. Positive divided by negative. Positive divided by negative is negative, so -5. And what is the symbol here? Well, we divided by a negative. Remember what happens when you divide by a negative? The inequality symbol switches directions. So now that's what we're going to graph. So that's exactly what I'm going to write over here. Y greater than 3/2x minus 5. Cool. Now I can identify the slope. The slope is 3/2. The y-intercept is -5. Okay, so you write it down. I'm already past that. I'm just showing you more examples. You want to shorter videos, then you have to follow my lead. So -5. So then it's going to be right here. -5. And now the slope is 3/2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 4, 1. 1, 2, 3, 1, 2. Okay? And now you trace the line. Is it going to be a solid or dashed? Exactly, it's going to be dashed because the look is a less than is not included. Okay, so arrowheads here, arrowheads here. I don't know what happened over here. And where am I going to shade? Well, it says y is greater than. Where is y greater than? Over here, so. Okay. Another method that you could do to graph your line, remember, to graph a line you only need 2 points. So what you could have done is, this is what we call a standard form of an inequality or equation. Alright, so you could have graphed the line by using the intercepts. What do you mean? Well, the y-intercept happens when x is 0. And the x-intercept happens when y is 0. Okay? So for example, if x is 0, 3 times 0 is 0. So that means that this disappears. Actually, let me show it to you over here. Alright, so this is what. So let's say x is 0. So 3 times 0 is 0, so this disappears. That leaves you with 2y less than 10, correct? Let me try on the other one as well. 3x minus 2y less than 10. Okay. So here, if y is 0, then that leaves you with 3x less than 10, correct? So let's see what happens. Let's try with the y-intercept. So x is 0, it leaves you with that. So if you divide by -2, you end up with -5. Look, -2, they cancel out. Bring down the y. Since you divided by a negative, this changes to greater than, and you get a 5. Making your point 0, -5, because x was 0. Now, here, if you want to find out what's going on, well, if y is 0, that leaves you with 3x. Now, 3x is less than 10. So, x is less than 10 over 3. Okay? So that, my friends, might pose a problem. But that's not difficult. Watch this. I can also try, if this is too difficult, this didn't work out, then try something like what I'm gonna do right now. 3x minus 2y less than 10. Okay, only use this method if you really have difficulties solving for y. Look, let me make this an even number. Okay, so I'm gonna put 2. X is 2. So if x is 2, 3 times 2 is 6, right? Now, if this is 6, I need this to be a 4 to match the 10, correct? So I'm gonna try y being -2. -2 times -2 is -4. Okay, so -2 times -2 is +4. Okay, and pretend that this is an equation and it's solved. All right, so that means I got another point. I got the point 2, -2. All right, this works. And then I had this one, so then I'm gonna go to the graph and I'm gonna do 0, -5 and 2, -2. So let's see if it worked. I'm gonna go to 0, -5 and I am going to do 2, -2. So you see that? It works. So on the standard form, all you have to do is give values for x and then try to match it with the value of y so you could get what's on the other side, pretending that it's an equation, and then you go back to the inequality. All right? Cool then. Let's try this one for size, but this one you're gonna try it, okay? And now, After you're done with that, I want you to try this one. And then I want you to try this one. Remember, you're solving for y. So you might want to subtract 5x and divide by -3, right? And remember, when you divide by -3, what's going on? Now try this one for size. Okay, good job. Now let's see what you would have gotten. So for y greater than or equal to 4, then look, it's going to be a solid line, horizontal, because if x is -1, y is 4. If x is -2, y is 4. If x is -3, y is 4. So the same thing. Put the arrowheads, label the line, and since it's greater, we're going to shade above the line. Here we go. The slope is 4/3, and we got a y-intercept of -4, so we got -4, and then 4 up, 3 to the right, 4 up, 3 to the right, and this is a solid line because it's less than or equal to, and also it's less than, so we're gonna shade below the line. Yep, the slope here is 5/3, okay, and the y-intercept is 5 right here. So if you cannot go 5/3 like that, then you go 5 down and 3 to the left, 5 down and 3 to the left, and that's it. This is your next one. Cool. All right, so we're done graphing inequalities. We're done solving linear inequalities. All right, thank you. See you on the next episode of How Do We Pass Our Common Core Algebra Regions.